Solving linear equations beyond the basics 2. Recall a linear equation is any equation whose highest power is 1 of a variable and there are no variables in the denominator or bottom of a fraction. You can have a fraction, just no variables in the denominator, which is the bottom, right? So in Beyond the Basics 2, we will focus on linear equations where distribution is required on one or both sides. This may require techniques learned in the Basics and Beyond the Basics 1 videos. When solving linear equations, these steps always help you solve. Simplify both sides if that's necessary. And of course, if you're distributing to parentheses, then that is simplifying a side. You're removing those parentheses. And then move all your variables to one side and all the numbers to the other if necessary. When I use the word numbers here, I'm referring to constants and numbers that are not attached to a variable. That would be a coefficient. For more information on solving linear equations, watch my Solving Linear Equations, the Basics video, and my other Beyond the Basics videos. All right, so here, 3 and then parentheses, v minus 2, close parentheses, equals negative 6. So the left-hand side, again, I'm going to focus on one side at a time. So the left-hand side, do we need to do any work to simplify it? So we always ask ourselves, do we need to simplify? Yes, we do. We need to distribute the 3. So I'm going to distribute the 3 to here. I'm going to say this is going to be 3v minus 6. Can I do anything else to the left-hand side? I have my equals here. No, there's nothing else I can do to the left-hand side of that equation. So now it is simplified. It took one step. Will it always take one step to simplify? No, it may take many, many, many steps. Now we go to the right-hand side. Do I need to do anything to simplify the number negative 6? And the answer is no, it's already simplified. So I'm going to just say, okay, that's already simplified negative 6 there. All right? And then I come back and I say, okay, what do I need to do now? Well, I look at this and I say, okay, I have multiple terms on one side and I have one term on the other side. When I have one term on one side and both sides are simplified, it's more efficient to move the thing like what's by itself. So what I mean is this is by itself, the number. Move the number from the other side. Take this negative 6 and move it over. How do I move a negative 6 over? When it's being subtracted, a 6 being subtracted, I add it. That cancels. Negative 6 plus 6 cancels. So that's going to end up being what? 3v equals negative 6 plus 6. By the way, that also cancels. Don't want to mark through it. You can or don't have to or whatever. But it cancels. It goes to 0. So then now I have 3v equals 0. And I want to solve for v. So I need to divide now by the 3 because 3 is times v multiplied. Those 3's divide out. All right? You were probably taught cancel. I was taught cancel. Books I used when I was in school said cancel. The only one in my office that says cancel now is over 30 years old because math teachers lied to everyone for so long that it's even in the dictionary as cancel, even though that's not what it is. Things cancel when they go to 0. So here this is v equals 0 divided by 3 is 0. So there is our final answer, v equals 0. And on this particular problem, I say, hey, check it. Hey, check it. And what I want to do is what I'm going to show you. However, it would be good for you if you're in someone else's class is to find out if they say check what they require to check. You can't just tell you. I don't know of a teacher that's going to say, oh, you just check it in your head and that's fine with me if I say check it. No. I mean, we have to have something written down so we can grade it, right, if we say check it. So here, check it. I want you to go back to the original equation and plug your number in for v that you found, okay? All the v's. In this case, there's 1. 3 and then parentheses, something minus 2. And I always plug my v or my variable into parentheses equals negative 6. So I'm going to take the v and plug it in here as 0. All right. Now I know I have parentheses inside parentheses and these parentheses aren't necessary. But again, anytime I'm plugging something into something, plugging a number into an equation or expression, I typically use parentheses to say, hey, I'm plugging something in here. So here, this is really 3 and then 0 minus 2. What is 0 minus 2? Well, it's negative 2. And that equals negative 6. And then we multiply 3 times negative 2, and that's what? Negative 6 equals, and we're just bringing this side down because there was no work to simplify. All right? But again, I would simplify the left-hand side and then simplify the right-hand side if I needed to. But there was nothing to simplify on the right side. Did this work? Yep. Negative 6 equals negative 6. Check. It's good. So then 4 times 2w minus 3 in parentheses equals 32. So this is basically the same problem with different numbers. Do we need to do any work on the left-hand side? Yes, we need to simplify that by distributing the 4. So I'm going to show my distribution here. All right, it's going to be 4 times 2w is 8w, and then 4 times negative 3 is minus 12 equals. Now, before I write the other side down, I want to finish the left-hand side. Is there anything else I need to do to the left-hand side to simplify it? No. So then it's already simplified. So then I'm going to bring down my 32 because that's only a number that's already simplified. Now we're in the case where we have multiple terms simplified equals a single term simplified. When it's simplified, you look at the thing by itself and it tells you what to move. So the thing by itself is what here? That's right, it's 32. So I'm going to move the negative 12. That's a negative 12. Don't say move the 12, by the way. If I ask my students what to move and they say 12, I just stare at them. All right, because there's not a 12 up here. There's a negative 12. How do I move the negative 12? I add 12 to both sides. All right, that cancels, goes to 0. 8w equals what? 44. 8w equals 44. 32 plus 12 is 44. And then I say what? Divide both sides by 8. So divide by 8 on both sides. That divides out. Does not cancel, divides out. And then I say, okay, is there any number that goes into both 44 and 8? Yep, 2 does. Because they're both even. Does anything bigger than 2 go into both 44 and 8? You say, well, 4 does, Mr. Gate. That's right, 4 does. Does anything bigger than 4 go into those? Does 8 go into 44? Nope. So if you take a 4 and divide it out of 44, that's what, 11? And how many times will 4 go into 8? 2. So this becomes 11 over 2, or 11 halves. W equals 11 halves. So here somebody said, Mr. Guess what if I gave you a decimal? That's fine in this case. It's 5.5. Exactly. But if it's 1/3 and you tell me 0.3, it's going to look like I blew your paper up with the points I take away. All right? My pen's going to explode on your paper. All right? So decimals are fine if they're exact, but anyway. 11 halves. 11 halves. And I don't want to mix number. We don't do mixed numbers in algebra unless you're explicitly told to. But again, if you're in someone else's class and they use mixed numbers, go ahead and use it. But mixed numbers in algebra typically are much more difficult to deal with than an improper fraction like 11 halves. Now, you need to know that 11 halves is 5.5 or 5.5, but 11 halves is a beautiful answer. All right? So here, 5 minus parentheses 2x plus 14 equals 10. This problem, again, we have to simplify the left-hand side, right? There's parentheses. In this problem in particular, students love to multiply that 5x by that parenthesis. But you tell me, is 5x multiplied by that parentheses? Nope. What's multiplied by that parentheses? Just the negative. Remember, pluses and minuses separate terms. And you never multiply one term times another term unless there's a multiplication something there, like parentheses or a dot to multiply. So here, then, you're only distributing this negative sign. So then the 5x stays out front, and then negative times 2x is minus 2x, and negative times 14 is minus 14. Okay? So you're taking that negative, and what that really means is cover this up and change the signs in here. Well, this is a plus, so change it, and that's right. So you're changing the signs. That's what a minus sign out front means. Change the sign of everything in the parentheses after it. Or you can think about negative times positive, negative, right? So am I done with the left-hand side as far as simplifying goes? No. I have to keep going here. So 5x minus 2x is what? 3x minus 14. Is there anything else I can do to the left-hand side? The answer is no. I am done simplifying the left-hand side. So now let's go to the right-hand side. Can I simplify 10? And I guess I'll stay with my... No, I can't. So I'll just bring it down. 10 and 10. If I have a bunch of steps there, I may draw an arrow down and put 10. That would be okay with me. But again, if you're in someone else's class, find out if that's okay with them. They may want you to write equals 10, even if it's 10 steps. 10 times, whatever. Okay? So here, to solve this is by itself. Move this over, right? Move the negative 14 over. So how do I move the negative 14 over? I add it to both sides. If I'm subtracting it, the opposite or inverse mathematical operation is to add. So the negative 14 plus 14 cancels. That's what you're trying to do, is cancel that because it goes to 0. And then you get 3x equals what? 10 plus 14 is 24. 10 plus 14 is 24. So 3x equals 24. And then I need to get x by itself, so I divide both sides by 3, okay? And then those 3's divide out, all right? And I'm not going to fight that too bad because, again, every teacher you ever had was taught out of a book unless they're, 24 years old and just got out of, school. They still probably were taught that it was canceled, okay? Because it's just been accepted in the math community. The lie's been accepted for years, okay? But it's just not in books anymore. Not that I see anyway. So then x equals 8. X equals 8. So then, got something on the screen there, sorry. X equals 8. And we're not checking this one. X is 8. We're done. Okay. So let's look at the next one. The next one, 20 equals 44 minus 8 times 2 minus m, right? The times because it's in parentheses. 2 minus m is in parentheses. Is the left-hand side simplified? Yep. So guess what? I'm not just going to leave it alone for now. I'm going to go to the right-hand side because this requires some work over here. So let's start over there. I'm just going to start with my equal sign. And if you want to, you can bring your 20 down here. Okay, I just like to do one side at a time. The 20 doesn't need any work. I'm going to go to the right-hand side and work on it. So the first thing I'm going to do is take this negative 8 and distribute it. That 8 gets multiplied by the parentheses because what's between the 8 and the parentheses? Nothing. Okay? And I know I'm pointing out things that many of you know, but why? Do you know why the 8 gets multiplied? Because up here, what's between the 5x and the parenthesis? A minus sign, so that's why we didn't multiply that. All right? Again, recognition pieces. We do a great job as math teachers on teaching you steps. You know all kind of steps, but you don't know when to use them sometimes. All right? So here, focus on when to use it, recognize what to do. There's nothing between the 8 and the parenthesis, so it gets multiplied. And there's a negative attached to the 8. So it's actually negative 8 times everything in the parentheses. So this is going to be 44 comes down, just brought down. And then minus 8 times 2 is minus 16. And minus 8 times minus m, a negative times a negative is positive. And 8 times m is 8m. Can I do anything else to the right-hand side? Yes, 44 minus 16 is what? 28 plus 8m. 28 plus 8m. Can I do anything else to that? No. So then I'm going to come down here and bring my 20 down because the left-hand side, we already said you can't do anything with it. So let's just go ahead and bring it down. I didn't know how many steps to bring it down before. That's why I waited until I finished the right side. Again, you could have brought the 20 down with each step as you did it. What do I do now? Well, what's the thing by itself? The thing by itself is the 20, so move the 28 over there with it. How do I move the 28? Well, the 28's positive, not because of this, but because there's an understood plus in front of it. So subtract 28 from both sides. That cancels, and I get negative 8 equals 8m. And then what do? I divide both sides by my coefficient of m, which is 8. Don't look at the left side. Look at the thing times the variable. I get this 8 from right here times the m. All right, so that divides out, and we're left with m equals negative 1, right? 8 over 8 is 1 over 1, and there's a negative there. So m equals negative 1. M equals negative 1. All right, let's see what we have next here. 3 times 3y minus 1 equals 4 times 3 plus 3y. So this one has parentheses on both sides, and that means we have to simplify both sides. So I'm going to start with the left. We read from left to right. I'm going to start with the left. So here, to simplify this side, I'm going to distribute my 3. So 3 times 3y is 9y. Minus 3 times 1 is 3, right? There's a positive times a negative. That's negative. And then 3 times 1 is 3. Can I do anything else to that side, left-hand side, 9y minus 3? And the answer is no, I can't do anything else to it. So now let's go to the right-hand side. How do I simplify the right-hand side? Well, I don't have anything I can do inside here, so I'll move to the distribution, right? Same thing, I should have said that. Couldn't do anything inside here, so that's why I distributed. So then 4 times 3 is what? 12, and then 4 times positive 3y is plus 12y. Can I do anything else to the right-hand side? The answer here is no. If I had 3 more steps on the right-hand side, I would just bring the left-hand side down 3 more times. Okay? Right? Just bring it down. You've already finished simplifying it. So then here it's simplified, and here I have multiple terms on each side. What's the best move? On this problem, there is no best move. You can choose to move the 9y, you can move the -3, you can move the 12, or you can move the 12y. Now, if you tell me to move the 3, then you're not correct. There is no 3. There's a -3. Okay? But as far as it goes, there's no best move. Any of the 4 moves are the same here. Any of the 4 moves here are the same. And remember, the only way that it would be a better move is if this was like 9 and 10. If they were 1 apart, you move the smaller one. But here, you just pick whatever. So I'm going to choose to move the -3. I'm going to add it to both sides. I'm going to add it to both sides. This cancels, and I get 9y equals 15 plus 12y. And then I'm going to come down here and say, okay, what do I do next? Well, now I have a best move. Once I make a choice, I chose to move -3. You could have chose to move 12 or 9y or 12y. Once you choose something to move, then you have a best move. Since y's are by themselves, I need to move the 12y over. So I'm going to do that by subtracting 12y from both sides. And when I do that, that cancels on the right. I get 9y minus 12y on the left, which is -3y equals 15. And then, how do I solve for y here? Well, I need to divide by -3. So your steps may look differently depending on what you chose to move here. But in the end, after you make that first move and there's a best move and then there's another best move, then we should all get to the same answer. All right? We should all arrive at the same solution. Y equals a positive divided by a negative is negative, and then 15 over 3 is 5. So y equals -5. And then we look at the next one here. 3 times d plus 2 equals d plus 30. So is there any work to do to the left-hand side to simplify it? And the answer is yes, distribute the 3. So if I distribute the 3, I get 3d plus 6, right? 3 times 2 is 6. And this is positive. Can I do any more work to 3d plus 6? No, I cannot do any more work. So equals, can I do any work to the right-hand side? I know it's 2 terms, but guess what? I cannot do any work, so it's going to be d plus 30. D plus 30 on the right-hand side. So then, now, again, 2 terms equals 2 terms are simplified. You got multiple terms. What's the best move? Well, 3d and d are not 1 apart, so there is no best move. I'm going to choose to move the d this time. Doesn't matter. I could always move the 6, the number from the left. I could always move the variable from the right. It doesn't matter. Okay? You can pick a method if you want to have make your recipe, so to speak. I'm going to move the d. So minus d from both sides. That's going to cancel. I'm going to be left with 2d plus 6 equals 30. And again, I want you to get to the point where you go, oh, wait a minute. If I'm canceling the d's, I need to do this and cancel at the same time. I want you to get there. I'm not showing that here, but I want you to get to that point where you can do both those steps at the same time. Save a little bit of work here. So 2d plus 6 equals 30. The thing by itself is 30, so we need to move the 6 over. How do I move the 6 over? I subtract it from both sides. So 2d equals 24. And I almost don't have room for this. Divide both sides by 2. And I get d equals 12. D equals 12. All right, so let's see here. Two parentheses p minus 1 close parentheses plus 3 equals p minus 3 open parentheses p plus 1, right? So here I got a lot of stuff going on. I got parentheses on both sides. I got multiple terms on both sides. I got all kind of stuff going on. So let's just look. Do I need to do any work to the left-hand side to simplify? Yes. There's nothing to do inside here, so I need to distribute that 2 to that parenthesis, right? So 2 times p is 2p minus 2 times 1 is 2, and then plus 3. Bring down my plus 3. Is there any more work I need to do to the left-hand side? And the answer is yes. I have like terms that I can combine. The negative 2 plus 3. Don't tell me 2 plus 3. That 2 is negative. Negative 2 plus 3. That minus sign goes with the 2, not the 2p. So then the 2p comes down, and then minus 2 plus 3 is plus 1. And then on the right-hand side, is there any work to do? Yep. I'm going to distribute what? Not 3. What am I going to distribute? Negative 3. So p and then minus 3p, right? Negative 3 times p, and then negative 3 times positive 1 is minus 3. And then, again, I have like terms, but this time the like terms are p's. P minus 3p is what? Well, 1 minus 3 is negative 2, and that's p, and then bring down my minus 3. Do I have any more work to do to the right-hand side? The answer is no. So, look, it's been convenient. We've had 2 steps on one side, 2 steps on the other, or less. We haven't had more yet. But if you have more, you just bring it down. Or if you don't have enough, you bring down the side that was shorter. Okay? So, here they both happen to be 2 steps to simplify. Now, again, is 1p, or the p's 1 apart, is what I should say. Or the p's 1, no, they're not. So, it doesn't matter what you move. I'm going to add 2p. I'm going to add 2p to both sides. Okay? I'm going to add 2p. Now, again, I want you to get to the point where you go, oh, guess what? I need to subtract 1 from both sides. I'm not going to show it here, but I want you to get to that point where you're doing those 2 steps at the same time. So 4p plus 1 equals negative 3. And now the thing by itself is negative 3, so we need to move the 1. We do that by subtracting from both sides. 4p equals negative 4, right? 2 negatives, you add them and keep it negative. And if 4, and I need to fix my p, it's a little high here. Okay, so then I do what? Divide both sides by 4. And the reason I did that, y'all, you can tell from the original problem that my p, if I draw my line, my p is obviously lowercase p. So if I write this, that's a 4 then a capital P, and that's 4 times a little p, right? So that matters. Math is case sensitive. You cannot change a little variable to a big variable, or lowercase to uppercase, or vice versa. In my class, I get upset about that and count off because they're different. There are actually formulas that people use that have a big R and a little r, or big V and little v, or something like that, have large uppercase and lowercase letters in the same equation or formula. So it does matter. So here, divide both sides by 4. The 4's divide out. P equals negative over positive is negative. 4 over 4 is 1. And if you want to, you can say, okay, this would be 1 over 1. All right. So P equals negative 1. P equals negative 1. And then 7 times 3x minus 2 in parentheses plus 5 equals 6 times 2x minus 1 in parentheses plus 24. So this is similar to the one. I guess there's some negatives in here. So it's similar. Is there any work to do on the left-hand side? Right? That's how we always. So then, yes, do this because there's no work to do inside there, so I go straight to distribution there. That's going to be 21x minus 14. What do I do with the plus 5? Bring it down, plus 5. Then we'll put my equals, but I'm not going to go to the right-hand side right now. I'm going to finish simplifying the left-hand side. I think that's less confusing. So here, when I do this, is there any work left to do here? Yes. Negative 14 plus 5. So 21x. They're different signs. You subtract them. 14 minus 5 is 9, and 14 is larger, so it is negative because 14 was negative to begin. If you owe $14 and pay 5 off, you still owe 9. All right, so can I do any more work to the left-hand side? And the answer is no. 21x minus 9 is simplified. On the right-hand side, again, nothing to do inside here, so I go to distribute the 6. And that's going to be 12x minus 6 and then plus 24. And again, there's work to do, the minus 6 plus 24, so this is 12x. Again, they're different signs. 24 minus 6 is 18, and 24 is bigger, so it's plus 18. Is there anything else I can do to the right-hand side? The answer is no. So now I'm ready to start moving things. I'm going to move the 12x. You can move the negative 9, the 21x, or the 18. The x's are not 1 apart, so it doesn't matter. It's all the same. So then 9x minus 9 equals 18. And then now there's a best move. Once I pick something to move, there's a best move. Now that's going to be to add 9 to both sides, right? Get rid of that minus 9 because the 18 is like it on the other side. Move it. 9x equals what? 27. 18 plus 9 is 27. And then we divide both sides by 9, and we end up with x equals what? 3, right? Those 9s divide out, and then 27 over 9 divides into 3 over 1, which is simplifies to 3. So there is our final answer for that one. All right, so I hope this helps out with solving some linear equations when there's parentheses involved. And remember, there's other videos in this series of solving linear equations if you need other types of help.